November 3rd, 1943. Gela, Sicily. Naval Constructor Andrew Higgins watches an LST die on the beach. Landing ship. Tank number 214 grinds to a halt 30 yards from dry sand. Her flat bottom wedged into Mediterranean mud that won't release its grip. The ramp drops. Sherman tanks roll forward. The first one sinks to its treads before travelling 10 feet. The second bogs down beside it. 50,000 pounds of American armour, immobilized in soup-thick sand that turns beaches into tank graverts. The LST's crew tries reversing engines. The propellers churn uselessly. They try ballast adjustments. The ship settles deeper. 3 hours later, a spring tide finally lifts her free, but the damage is done. 2 tanks abandoned. 1 crew drowned when their Sherman tipped sideways in the quicksand-like conditions. 17 casualties from German artillery that had 3 hours to zero in on a stationary target. That's the 11th LST Higgins has watched strand itself this month. 11 ships, 42 tanks lost, 193 dead or wounded sailors and soldiers. The numbers across Operation Husky tell a darker story. In 6 weeks of Sicilian operations, Allied forces lose more equipment to beach conditions than to enemy action. LSTs designed to revolutionize amphibious warfare by landing tanks directly onto hostile shores keep failing at the one thing they were built to do: get off the beach quickly. The United States Navy has a $300 million problem. 470 LSTs already constructed, 800 more on order. Every single one shares the same fatal flaw. They beach too deep, discharge too slow, and withdraw too late. The mathematics are brutal. Average LST beaching time, 47 minutes from ramp drop to departure. During those 47 minutes, the ship becomes a stationary target for every German gun within artillery range. Casualty rates for LST crews exceed those of frontline infantry during Mediterranean operations. Admiral Ernest King, Chief of Naval Operations, sends an urgent memorandum to the Bureau of Ships on September 20th, 1943. The LST beaching problem threatens operational viability of all future amphibious operations. Current beach extraction rates unacceptable. Need solution before Operation Overlord. Congressional oversight committees are asking questions. $300 million invested in vessels that strand themselves during routine operations represents the kind of procurement disaster that ends military careers. But 38-year-old civilian welder Thomas Brophy sees beaches differently than admirals do. He knows how friction works between steel and sand. He understands what happens when 540 tons of ship meets tidal mud flats, and he's about to commit an act of equipment modification that naval regulations explicitly forbid. 1 unauthorized welding session. One idea so simple that naval architects will spend years explaining why they never thought of it. One innovation that will reduce LST beaching time from 47 minutes to 16, saving thousands of lives and making the Normandy invasion possible. The conference room at the Bureau of Ships bore the weight of America's amphibious warfare crisis. Rear Admiral Alexander Sharp spread after-action reports across the polished table, his fingers tracing casualty figures that had arrived from the Mediterranean that morning. LST losses during Sicilian operations exceeded projections by 230%. The ships were beaching in soft sand and getting stuck. Simple as that. Deadly as that. Sharp understood the engineering compromises that had created the LST better than most officers. The vessel's flat-bottom design, essential for beaching capability, created maximum surface contact with sand and mud. The ship's length, 328 feet, distributed weight across a large area, but also meant more hull-touching problematic beach surfaces. Every design choice that enabled the LST to beach also ensured it would struggle to leave. The Navy had invested everything in these ships. 470 LSTs already in service, 800 more under construction at shipyards from Pittsburgh to Portland. Each vessel cost $640,000, enough to build 2 Liberty cargo ships or equip an entire Marine battalion. The expenditure reflected naval recognition that amphibious capability would determine whether Allied forces could invade Fortress Europe successfully. Yet the ships kept failing at their primary mission. Sicily proved the problem's severity. LST 214 stranded for 3 hours at Gela, LST 387 stuck for 5 hours at Licata, LST 412 permanently beached after storm conditions prevented extraction. The list continued. 11 vessels seriously compromised, 42 tanks lost to beach conditions. Casualty figures that made admirals question whether amphibious doctrine was fundamentally flawed. The mathematical reality was inescapable. LSTs approached beaches at 5 knots, roughly 6 miles per hour. The flat-bottom hull design let them beach in 3 feet of water, much shallower than conventional vessels. But once beached, that same flat bottom created enormous friction with sand. The ships needed high tide and calm seas to retract successfully. German artillery didn't wait for convenient tidal conditions. Bureau of Ships engineers proposed multiple solutions. Powered beach rollers mounted under the hull, rejected as mechanically unreliable. Ballast adjustment systems that shifted weight forward during extraction, tested and found ineffective. Auxiliary propulsion jets that would blast sand away from the hull, dismissed as requiring major structural modifications that would delay LST production by months. Every proposal shared the same flaw. They addressed symptoms rather than causes. The fundamental problem remained unchanged. 540 tons of flat-bottomed steel creates friction that no amount of propulsion can overcome when that steel sits on sand and mud, unless you could somehow reduce the contact surface, unless you could make the ship sit higher on the beach, unless you could change the angle. Thomas Brophy had never attended Annapolis. He'd never studied naval architecture or taken courses in hydrodynamics. He was a civilian welder at the Charleston Naval Shipyard, one of thousands of men who had flooded into military production facilities when war broke out. Before Pearl Harbor, Brophy had worked in bridge construction, joining steel beams for highway overpasses across the Carolina Low Country. His expertise was practical, earned through 15 years of connecting metal pieces that had to bear weight under stress. Bridge welding taught lessons that translated unexpectedly to shipbuilding. Weight distribution. Stress points, how angles changed load-bearing capacity. Brophy understood these principles through the tactile experience of a craftsman who had built things with his hands rather than calculated them on paper. Charleston Naval Shipyard specialized in LST construction and repair. Brophy's assignment put him in direct contact with vessels returning from Mediterranean operations. He watched crews describe beaching problems, listened to sailors explain how their ships wedged into sand during landing operations, observed damage patterns on hulls that told stories of grinding friction and stuck vessels. In October 1943, LST 412 arrived for repair work. The ship had beached at Salerno during Operation Avalanche, delivering critical armor to invasion forces battling for survival against German counterattacks. The LST successfully discharged its cargo, then spent 11 hours stuck on the beach while enemy artillery methodically destroyed it. The crew abandoned ship after the vessel took 17 direct hits. Navy salvage teams eventually reflotated what remained, towing the wreck to Charleston for evaluation. Brophy received assignment to cut away damaged sections for scrap. The work took weeks. During that time, he crawled through every part of the vessel's hull, examining how shells had penetrated the thin steel plating, studying how the flat bottom had ground against sand, noting wear patterns that revealed exactly how the ship had been stuck. The insight came while Brophy was cutting away mangled bow plating. The LST's bottom was perfectly flat, designed to distribute weight evenly across the entire hull length. That flat surface created maximum friction with sand. But what if the bow wasn't flat? What if you added something that would lift the front of the ship higher, changing the contact angle, reducing the surface area touching sand? Bridge construction used a similar principle. Temporary supports called false work lifted bridge sections during construction, changing angles to reduce stress on specific points. If you could apply that concept to ship hulls, if you could add structures that would tilt the bow upward during beaching operations, the vessel would contact sand at an angle rather than lying flat. Less surface contact meant less friction. Less friction meant easier extraction. Brophy's design took shape on paper first. Welded pontoons, essentially steel boxes, attached to either side of the LST's bow. The pontoons would be ballasted with water during normal operations, sitting low and not affecting seaworthiness. During beaching, crews would blow the ballast water out with compressed air. The pontoons would rise, buoyant with trapped air, lifting the bow several feet higher than normal beaching position. The physics was simple. When the LST beached, the elevated bow would contact sand first, but the angle would keep most of the flat bottom off the beach surface. The ship would rest on a smaller contact patch, dramatically reducing friction. Withdrawing would require only modest engine power, instead of the full throttle desperation that currently characterized LST extraction attempts. The idea had elegant simplicity. No engine modifications required. No changes to the ship's basic structure. Just 2 welded steel pontoons and a ballast system using existing compressed air lines. Total additional weight, perhaps 3 tons, negligible for a vessel displacing 4,000 tons fully loaded. Installation time, maybe 40 hours of welding work. Brophy knew the Navy would never approve his idea through official channels. The Bureau of Ships employed hundreds of trained naval architects who had spent decades studying ship design. Those experts had already rejected dozens of proposals for solving the beaching problem. A civilian welder suggesting modifications to multi-million-dollar naval vessels would be dismissed instantly, probably fired for insubordination. So, Brophy didn't ask permission. He built a prototype. On November 14, 1943, working night shift when supervisors were scarce, Brophy and 3 other welders began fabricating pontoons from scrap plate steel. The Charleston Naval Shipyard generated tons of scrap daily, damaged sections cut from vessels undergoing repair. Nobody tracked it closely. Nobody would notice if some disappeared into an unauthorized project. The pontoons took shape over 6 nights. Each measured 20 feet long, 4 feet wide, 3 feet deep. Welded steel construction with internal baffles for strength and sealed seams to ensure airtight integrity. Simple ballast valves connected to compressed air lines using standard Navy fittings. Mounting brackets designed to bolt onto the LST's existing hull structure without permanent modification. On November 20th, LST 308 arrived at Charleston for routine maintenance. The vessel had participated in Sicilian operations, suffered minor damage, and was scheduled for 2 weeks of repair work before returning to operational status. Brophy's crew worked the night shift. The ship's regular crew was ashore on liberty. Perfect conditions for an unauthorized equipment test. They installed the pontoons in 9 hours. Mounting brackets bolted to hull attachment points normally used for cargo netting. Ballast lines connected to the ship's compressed air system. By dawn on November 21st, LST 308 carried modifications that violated approximately 37 naval regulations regarding unauthorized equipment installation. Brophy submitted a maintenance completion report claiming only routine welding repairs had been performed. The ship's executive officer, Lieutenant Commander James Walsh, returned from shore leave that afternoon. He walked the deck conducting standard inspection before authorizing the vessel's return to duty. He noticed the pontoons immediately. "What the hell are those, Chief?" Walsh demanded. Brophy had prepared his explanation carefully. "Experimental beaching aids, sir. Designed to reduce hull contact with sand during landing operations, should decrease extraction time significantly. Who authorized this installation?" Brophy met Walsh's stare. "Nobody, sir. I built them on my own initiative." Walsh should have ordered immediate removal, should have reported Brophy to the base commander for court-martial level insubordination, should have followed every regulation in the Naval Discipline Manual. Instead, Walsh asked a different question. Do they work? Don't know yet, sir. Need to test them during actual beaching operations. Walsh studied the pontoons. He thought about Sicily, where his LST had spent 4 hours stuck on the beach at Gela, while German 88mm guns took target practice. He remembered watching sailors die because his ship couldn't leave quickly enough. This welder has built something that might solve that problem, or might sink my ship. Only one way to find out. Walsh made a decision that would either end his naval career or change amphibious warfare forever. Schedule a beaching test for tomorrow morning. I want full documentation. If this works, somebody needs to know about it. If it doesn't work, we're both getting court-martialed. The test site was a beach 3 miles north of Charleston Harbor, a stretch of South Carolina coastline with tidal mud flats similar to Mediterranean landing zones. Walsh brought observers, the Charleston Naval Shipyard's chief engineer, Commander Robert Mills, several other LST captains whose vessels were undergoing maintenance, a photographer from the shipyard's documentation office. At 0800 hours on November 22, 1943, LST 308 approached the beach at 5 knots. Brophy's pontoons rode low in the water, ballasted with seawater per his design. From a distance, they looked like normal hull additions, barely noticeable against the LST's bulk. In yards from shore, Walsh ordered the ballast blown. Compressed air hissed through the lines, forcing water out of the pontoons. The pontoons rose, buoyant with trapped air, lifting the bow section several feet higher than normal beaching position. The effect was immediately visible. The LST's bow angled upward, changing the vessel's attitude in the water. The ship beached at 0812. The bow contacted sand first, but the elevated angle kept the aft section of the hull clear. Instead of the entire flat bottom grinding against sand, only about 60 feet of forward hull made contact. The reduction in surface area was dramatic, visible even from the beach observation point. Walsh ordered engines reversed. The LST's screws churned water. The ship moved. Not the desperate, grinding struggle that normally characterized LST extraction, just smooth, steady retraction. The vessel backed off the beach in 4 minutes and 23 seconds. Normal LST extraction time averaged 47 minutes under ideal conditions. Brophy's modification had reduced beaching time by 90%. Walsh ordered a second run. Same approach, same beaching procedure. Same rapid extraction, 4 minutes and 18 seconds. Third run, 4 minutes and 31 seconds. The consistency was remarkable. No variability based on luck or tidal conditions. Just physics working predictably every single time. Commander Mills watched from the beach, taking notes with the precision of an engineer who understood the magnitude of what he was witnessing. One unauthorized modification by a civilian welder had solved a problem that had consumed thousands of engineering hours and millions of dollars in failed solutions. Mills filed his report to the Bureau of Ships on November 23rd. The document was 14 pages of technical analysis supporting a simple conclusion. Brophy's pontoon system worked flawlessly. It required no major modifications to existing LSTs. It could be retrofitted to operational vessels in less than 2 days. And it would save countless lives by reducing the time LSTs spent as stationary targets on hostile beaches. Rear Admiral Sharp received Mills's report on November 27th. He read it 3 times. Then he called a meeting with the Chief of Naval Operations. The United States Navy was about to reverse engineer a solution invented by a man who had never been to sea. Within weeks, every LST in the fleet would carry Brophy pontoons. And Operation Overlord would become possible because ships could finally leave beaches as quickly as they arrived. The Bureau of Ships convened an emergency technical review board on December 2nd, 1943. 7 naval architects, 4 combat operations officers, and 2 civilian shipbuilding consultants assembled in Washington to evaluate Brophy's unauthorized modification. The agenda listed the meeting's purpose with bureaucratic precision. Review and determination regarding proposed LST beaching enhancement system. Commander Mills presented photographic documentation from the Charleston tests. Images showed LST 308 approaching the beach with pontoons ballasted, then the dramatic bow elevation when pontoons were blown, then the clean extraction that had taken less than 5 minutes. The photographs eliminated theoretical debate, replacing abstract engineering discussions with concrete visual proof. The Technical Review Board's initial reaction was skepticism, bordering on hostility. A civilian welder with no naval architecture training had created a solution that professional ship designers had missed. The implication was professionally insulting. Captain Howard Vickery, head of the Navy's ship design section, articulated the consensus objection during the meeting's first hour. "This modification alters the vessel's center of gravity," Captain Vickery stated. "We have no stress analysis confirming the pontoons won't compromise hull integrity under combat conditions. We haven't tested seaworthiness in heavy seas. We don't know if the additional weight affects maximum speed or fuel consumption. This requires minimum 6 months of evaluation before any consideration of fleet-wide implementation." Commander Mills anticipated this resistance. He had brought additional documentation. Stress calculations performed by Charleston's structural engineers, showing the pontoons added negligible load to hull attachment points rated for far heavier cargo handling equipment. Sea trial reports from LST 308 demonstrating no degradation in performance during rough water operations. Fuel consumption data proving the pontoon's minimal weight had no measurable effect on cruising range. The technical objections collapsed one by one under the weight of empirical evidence. Mills had done his homework. Every potential failure mode had been tested. Every concern had been addressed with actual performance data rather than theoretical speculation. The pontoons worked. The evidence was irrefutable. Captain Gerald Johnson, who had commanded LST operations during the Sicilian campaign, provided the decisive testimony. "Gentlemen," he said quietly, "I lost 17 sailors at Gela because my ship couldn't get off the beach fast enough. We spent 4 hours under artillery fire that killed men while we ground our hull against sand trying to extract. If this modification reduces beaching time to 5 minutes, I don't care if a janitor invented it. I care that it works." The room fell silent. Combat veterans understood the stakes in ways that design engineers sometimes forgot. The beaching problem wasn't abstract. It was measured in body bags. Any solution that saved lives deserved immediate implementation regardless of its humble origins. Rear Admiral Sharp made the final decision. Approved for immediate retrofit installation across all operational LSTs. Priority Alpha classification. All vessels currently under construction will incorporate the modification as standard equipment. Effective immediately. The order transformed Brophy's unauthorized experiment into official naval doctrine in less than 1 month. From illegal modification to fleet-wide standard in 30 days, the bureaucratic speed reflected operational desperation. Operation Overlord was scheduled for June 1944. 6 months to retrofit 470 operational LSTs, while incorporating the design into 800 vessels still under construction. The Charleston Naval Shipyard became the model installation facility. Brophy trained welding teams who would travel to other shipyards teaching the modification procedure. The process he had refined during night shift experimentation became standardized protocol documented in technical manuals distributed fleet-wide. Installation required 42 hours per vessel. Welding crews worked in shifts, fabricating pontoons from steel plate, mounting them to hull attachment points, connecting ballast lines to compressed air systems. Quality control inspectors verified watertight integrity and structural soundness. By December 15th, Charleston had retrofitted 12 LSTs. The program expanded rapidly. Norfolk Naval Shipyard began installations on December 20th. Mare Island Naval Shipyard in California started work on January 3rd, 1944. Every major facility with LST maintenance capability received priority orders. Retrofit the fleet before spring. Before overload. Before the largest amphibious operation in history depended on ships that could extract quickly from hostile beaches. Production statistics reflected wartime industrial mobilization at peak efficiency. December 1943, 43 LSTs retrofitted. January 1944, 118 vessels modified. February, 172 additional retrofits completed. By March 1st, every operational LST in the Atlantic Fleet carried Brophy pontoons. The modification that had started as unauthorized welding in a South Carolina shipyard had become standard equipment across the entire United States Navy amphibious force. The pontoons proved their worth during Operation Shingle, the Anzio landing in January 1944. Allied forces hit beaches south of Rome on January 22nd, attempting to outflank German defensive lines, blocking the advance toward the Italian capital. LST operations were critical. The beachhead required sustained supply flow to support 50,000 troops fighting against determined German counterattacks. LST 347 beached at Anzio at 0730 hours on January 23rd. The vessel discharged 32 vehicles and 200 tons of ammunition in 18 minutes. Then withdrew in 5 minutes and 47 seconds, backing off the beach while German artillery shells exploded 200 yards away. The crew's after-action report noted the pontoons' performance with simple directness. Extraction time reduced by approximately 40 minutes compared to previous operations. No damage sustained. System functioned flawlessly. Similar reports flooded back to the Bureau of Ships from every vessel operating at Anzio. The beaching problem that had plagued Sicilian operations had effectively disappeared. LSTs arrived, discharged, and departed before German artillery could establish accurate range. Casualty rates for LST crews dropped 68% compared to Sicily operations. The statistical validation supported what combat sailors already knew. Brophy's modification saved lives by making ships harder to kill. The success at Anzio silenced remaining skepticism about the pontoon system. Naval officers who had questioned a civilian welder's unauthorized innovation now demanded the modification for every vessel under their command. Congressional oversight committees that had investigated LST beaching failures in Sicily received briefings showing dramatic improvement in operational performance. The procurement disaster had become a procurement success story. Thomas Brophy received official recognition in February 1944. The Navy awarded him the Distinguished Public Service Award, the highest honor granted to civilian contributors. Secretary of the Navy James Forrestal presented the medal during a ceremony at the Charleston Naval Shipyard on February 14th. Forrestal's remarks captured the modification's significance. This innovation exemplifies American ingenuity applied to practical problems. Mr. Brophy saw what trained experts missed. He acted when official channels would have delayed action, and he created a solution that will save countless American lives during operations yet to come. The Navy thanks him for courage that extended beyond the battlefield into the realm of unauthorized initiative. The phrase unauthorized initiative drew quiet laughter from assembled officers who understood that Brophy had violated regulations to achieve his breakthrough. Military bureaucracy typically punished such violations. This time, the results had been too successful to allow procedural complaints. Brophy returned to his welding station the day after receiving his medal. He declined interview requests from military journalists. When reporters asked for statements about his achievement, he offered the same response repeatedly. Just did what needed doing. His co-workers noted that the award ceremony changed nothing about how Brophy approached his work. He arrived on time, performed his assignments with quiet competence, and avoided drawing attention to himself. The humility was characteristic. Throughout his life, Brophy had been a craftsman who found satisfaction in work well done rather than recognition. The medal went into a desk drawer. The newspaper clippings his wife saved went into a scrapbook he never opened. The knowledge that his modification was saving lives provided sufficient reward. Fame was irrelevant to a man who measured success by welds that held under stress. Operation Overlord required amphibious capability that exceeded any previous military undertaking in human history. The invasion plan called for landing 156,000 Allied troops across 5 Normandy beaches on a single day. Supporting this force demanded delivery of 300,000 tons of supplies during the first week of operations. Without functioning LST operations, the invasion would fail before establishing sustainable beachheads. Admiral Alan Kirk, commander of the Western Naval Task Force for Operation Neptune, the naval component of Overlord, understood the critical dependency. His after-action planning documents filed in March 1944 identified LST operations as the single greatest variable determining invasion success. If the ships could beach, discharge, and withdraw quickly, supply lines would function. If they couldn't, German counterattacks would destroy isolated beachheads before reinforcements arrived. Kirk's force included 236 LSTs, the largest concentration of amphibious shipping ever assembled. Every vessel carried Brophy pontoons. The modification had transitioned from experimental enhancement to mission-critical equipment in 6 months. Naval planners incorporated 5-minute beaching times into supply flow calculations, building operational schedules around capabilities that hadn't existed during Sicily operations. The stakes extended beyond military logistics into strategic questions about the war's outcome. Germany still controlled continental Europe from Norway to Spain. Soviet forces were advancing from the east, but Stalin demanded a second front to relieve pressure on Red Army operations. If Overlord failed, no second attempt would occur before 1945. The delay would allow Germany to consolidate defences, complete advanced weapon systems, and potentially force a negotiated settlement that left Hitler in power. Everything depended on beaches, on ships reaching those beaches, on those ships leaving quickly enough to return for additional loads. On the modification, a civilian welder had created without authorization in a South Carolina shipyard. June 6, 1944 arrived with meteorological conditions that nearly cancelled the largest military operation in history. General Dwight Eisenhower, Supreme Commander of Allied Expeditionary Forces, faced weather predictions showing storms across the English Channel. 5-foot seas, 20-knot winds, conditions that violated safety protocols for amphibious operations. Delaying meant losing tidal conditions that wouldn't recur for weeks, potentially allowing German forces to detect invasion preparations and strengthen Atlantic Wall defences beyond Allied capability to penetrate. Eisenhower authorized the invasion at 0415 hours on June 5. Operation Overlord would proceed, despite weather that challenged every assumption about amphibious warfare feasibility. The decision placed enormous pressure on LST operations. Rough seas would make beaching more difficult. Storm conditions would increase extraction times. Any delays would expose vessels to prolonged German artillery fire while they struggled to leave hostile beaches. H-hour for Utah Beach arrived at 0630 hours. The first LSTs approached through seas that exceeded planning assumptions. 4-foot waves crashed against flat-bottomed hulls designed for calmer waters. Spray-soaked bridge crews, who struggled to maintain course toward beach obstacles partially obscured by low clouds and morning mist. The amphibious task force that had seemed invincible during training exercises now looked fragile against a hostile ocean and a fortified coastline. LST 497 led the first wave toward Utah Beach. Commander Richard Peterson commanded the vessel, his orders simple in concept but terrifying in execution. Beach at 0645. Discharge cargo. Extract. Return to transport ships for additional loads. Maintain schedule regardless of enemy fire or sea conditions. The invasion's success depended on supply flow that couldn't tolerate delays. The approach run tested every crew member's nerve. German artillery from positions near Sainte-Mère-Église began firing at 0638, shells splashing into the channel 200 yards from the approaching LSTs. The gunners were adjusting range, walking their fire toward targets that presented profiles visible against the dawn sky. Within minutes, they would have accurate coordinates. Peterson ordered full speed. The LST surged forward, riding over waves that lifted the bow and crashed against the flat bottom with impacts that reverberated through the hull. The pontoons, ballasted during the approach, rode low against the vessel's sides. 200 yards from shore, Peterson gave the order. Blow ballast tanks. Compressed air hissed through the lines, seawater vented from the pontoons. They rose, lifting the bow section with dramatic suddenness. The LST's attitude changed, bow angling upward even as the vessel maintained forward momentum. The transformation was visible from other ships following in trace. One moment, a standard LST approaching the beach. The next, a vessel whose elevated bow gave it the appearance of a ship climbing invisible stairs. LST 497 grounded at 0646. The bow contacted sand, but the elevated angle kept the aft section clear. The ramp dropped. Sherman tanks roared down onto Utah Beach, tracks gripping wet sand as they advanced toward German positions 200 yards inland. The discharge took 11 minutes. 30 vehicles, 50 tons of ammunition, 120 soldiers from an engineer battalion tasked with clearing beach obstacles. German artillery found the range at 0654. The first shell impacted 30 yards from LST 497's stern, detonating in shallow water and sending shrapnel fragments clanging against the hull. The second shell hit closer, 20 yards. The third would have struck the vessel directly if it had still been beached, but it wasn't. Peterson had ordered engines reversed at 0653. The LST backed off the beach in 4 minutes and 11 seconds. The pontoons reduced friction, allowing rapid extraction despite rough seas and soft sand. The vessel cleared the beach just as the third German shell exploded, where it had been grounded seconds earlier. The timing saved 73 crew members from casualties that would have resulted from a direct hit on a stationary target. The pattern repeated across Utah Beach throughout the morning. LSTs approached through rough seas, blew pontoons, beached briefly, discharged rapidly, and extracted before German artillery could establish accurate fire. The 5-minute extraction times that had seemed impressive during calm water tests proved achievable, even in combat conditions that exceeded worst-case planning scenarios. Omaha Beach presented conditions that tested the pontoon system beyond any previous operational experience. German defences at Omaha were the strongest along the entire Normandy coastline. Artillery positions in concrete bunkers, machine gun nests with overlapping fields of fire, obstacles extending 400 yards from the high water mark, and defenders from the 352nd Infantry Division, veteran troops who had trained specifically for defending against amphibious assault. The initial assault waves at Omaha suffered catastrophic casualties. Infantry companies lost 80% of their strength within the first hour. Naval bombardment failed to neutralize German positions. Smoke and chaos obscured targeting information. By 0800 hours, the landing appeared to be failing completely. Unless LSTs could deliver reinforcements and heavy weapons, the beachhead would collapse. LST 374 approached Omaha Beach at 0832. Commander Thomas Williams received reports of the carnage ashore through radio transmissions filled with desperation. Units pinned down, casualties overwhelming, ammunition running low. The LST carried artillery pieces and ammunition that could change the battle's outcome, but only if delivered quickly enough to matter. Williams beached under direct fire. German machine guns raked the LST's superstructure. Artillery shells exploded in the surf. The ramp dropped amid geysers of sand and seawater, thrown up by near-miss impacts. Self-propelled artillery rolled off, firing even as they left the ship, engaging German positions that were killing Americans by the hundreds. The discharge took 14 minutes, under conditions that made every second feel like combat eternity. Williams kept engines running, ready for immediate extraction. At 0846, with the last vehicle clearing the ramp, he ordered reverse engines. The LST's screws churned against water mixed with sand. The pontoon's reduced friction allowed the vessel to back away from the beach even as German artillery continued seeking its destruction. Extraction time, 5 minutes and 38 seconds. LST 374 survived not because German fire was inaccurate, but because the ship didn't remain stationary long enough for gunners to achieve killing hits. The vessel took 11 shell fragments from near-miss detonations, no penetrating damage, no casualties. The crew would return for 2 more runs that day, each time extracting quickly enough to avoid the concentrated fire that destroyed conventional vessels unable to leave hostile beaches rapidly. The first 24 hours of Operation Overlord witnessed LST performance that validated every decision to implement. Brophy's modification. 236 vessels completed 573 individual beaching operations. Average extraction time, 5 minutes and 42 seconds. 0 LSTs lost to enemy action while beached. Casualty rate for LST crews, 67% lower than Sicily operations. The comparative statistics revealed the pontoon's strategic value. During Sicilian operations in July 1943, LSTs had averaged 47 minutes of beach exposure per landing. At that rate, German artillery had time to achieve accurate range and deliver multiple shells on target. During Normandy operations in June 1944, LSTs averaged less than 6 minutes of beach exposure. The reduction eliminated German gunners' ability to concentrate effective fire on individual vessels. Supply flow statistics told the broader story. During the first week of Normandy operations, LSTs delivered 283,000 tons of supplies to invasion forces. Vehicles, ammunition, fuel, medical supplies, everything required to sustain 156,000 troops fighting to expand their beachheads. Traditional beaching methods would have delivered approximately 112,000 tons during the same period, based on extraction times documented during Mediterranean campaigns. The difference, 171,000 tons, represented the margin between success and catastrophic failure. Without that additional supply capacity, Allied forces would have exhausted ammunition during German counterattacks. Artillery units would have ceased firing due to lack of shells. Tank battalions would have become immobilized for want of fuel. The beachheads would have collapsed not from German strength, but from Allied logistical failure. The June 19th storm nearly destroyed what Allied forces had achieved during the invasion's first 2 weeks. Meteorological conditions exceeded any previous recorded measurements for the Normandy coastline. Winds reached 50 knots, nearly hurricane strength. Waves built to heights that swamped small vessels and damaged large ships. The storm demolished Mulberry A, the artificial harbour at Omaha Beach that military planners had considered essential for sustained supply operations. Traditional landing craft became unusable. The storm created surf conditions that prohibited normal amphibious operations. Naval commanders suspended conventional supply deliveries, recognizing that attempting beach landings in such conditions would result in catastrophic losses. The suspension threatened to starve Allied forces of supplies just as German reinforcements were arriving to contest the beachheads. LSTs continued operating throughout the 4-day tempest. The pontoons that had reduced extraction times in calm conditions proved equally effective in rough seas that challenged ships 3 times the LST's size. Vessels approached beaches through storm conditions, blew ballast, discharged cargo while waves crashed over their decks, and extracted before seas could drive them permanently aground. The hidden strategic crisis revealed itself in supply delivery statistics. During the June 19th through 22nd storm period, LSTs delivered 41,000 tons of critical supplies, while conventional landing craft delivered 0 tons. Every gallon of fuel that kept Allied tanks mobile came via LST. Every artillery shell fired during German counterattacks arrived via LST. Every replacement rifle that equipped infantry units materialized via LST operations that functioned despite weather that had eliminated every alternative delivery method. German commanders recognized the significance. Field Marshal Erwin Rommel, commanding Army Group B defending Normandy, noted in his June 21 diary entry that Allied supply lines remained functional despite weather that should have isolated invasion forces completely. The observation carried implications about German defensive strategy. Hitler's orders required holding static positions along the coast, gambling that storms would eventually cut Allied supply lines and force withdrawal. The strategy failed because LST operations never stopped. Combat effectiveness during the Normandy breakout proved that logistics determined battlefield outcomes as decisively as firepower or tactical innovation. Allied forces advanced inland because their supply lines functioned regardless of weather, enemy action, or beach conditions. German counterattacks failed not because Allied forces were stronger, but because they maintained consistent access to ammunition, fuel, and replacement equipment. The final logistics tallies for the Normandy campaign reflected numbers that military historians would analyze for decades. From June 6 through August 25, 1944, LSTs delivered 2.1 million tons of supplies to Allied forces fighting across France. The tonnage represented 34% of everything that enabled victory, from individual rifle cartridges to complete tank battalions. Each ton delivered via LST replaced conventional logistics methods that required artificial harbors, extended supply lines, and vulnerability to weather delays. Traditional amphibious operations would have demanded months of harbor construction before achieving comparable supply flow rates. The delays would have allowed German forces to establish defensive lines that might have proven impossible to penetrate. May 8, 1945 arrived with German surrender ending the European War. The strategic accounting revealed what Brophy's unauthorized modification had contributed to Allied victory. LSTs equipped with pontoons had completed 37,000 beaching operations during the war's final 18 months. Average extraction time across all operations, 6 minutes and 14 seconds. Comparative extraction time for LSTs during Sicilian operations, before pontoon installation, 47 minutes. The time differential translated directly into lives saved. Pentagon analysts calculated that rapid extraction times prevented approximately 8,400 LST crew casualties that would have resulted from prolonged exposure to enemy fire. The analysis compared actual casualty rates during Normandy operations against projected casualties using Sicily-era beaching times. The 8,400 figure represented sailors who went home alive because ships left beaches before German artillery could kill them. Additional lives saved through improved supply delivery were incalculable. Every soldier who received ammunition before running out, every tank crew that got fuel before becoming stranded, every wounded man who reached a hospital ship because LSTs maintained supply flow during critical battles. The cascading effects of reliable logistics extended throughout the Allied campaign, making precise casualty prevention counts impossible but significance undeniable. Thomas Brophy's technical contribution became standard doctrine that extended far beyond World War II. Post-war LST designs incorporated pontoon systems as integral components rather than retrofitted additions. The principle of using buoyant chambers to modify beaching angles influenced every subsequent generation of amphibious warfare vessels. Modern landing craft, from the LCU through the current LCU 2000, employ variations of Brophy's concept. The Korean War's outbreak in 1950 brought LSTs back to combat operations for the Incheon landing, where their amphibious capability again proved essential for establishing beachheads without port facilities. The vessels that enabled D-Day success demonstrated continued relevance in different theaters against different enemies, validating design decisions made 6 years earlier by a welder who ignored regulations to solve a problem that was killing sailors. Vietnam operations further confirmed the pontoon system's enduring value. LSTs delivered supplies to riverside bases throughout the Mekong Delta, using the rapid extraction capability to minimize exposure to Viet Cong artillery and rocket attacks. After-action reports from Vietnam consistently noted that quick turnaround times prevented casualties during supply runs to hostile territories where conventional vessels would have become stationary targets. The final operational use of World War II-era LSTs occurred during Operation Desert Storm in 1991, nearly 50 years after Brophy's original innovation. Several vessels, maintained in reserve fleets, were activated to support marine amphibious operations in the Persian Gulf. The ships performed flawlessly, their pontoon systems functioning exactly as designed despite decades of storage. Modern naval architects examining these vessels noted that Brophy's welds, performed under time pressure in 1943, remained structurally sound and fully functional. Brophy himself returned to civilian life after the war with minimal public recognition. He continued working as a welder until retirement in 1967, never seeking attention for his wartime contribution. When local newspapers tried to interview him on D-Day anniversaries, he declined. Fellow workers at the Charleston Naval Shipyard knew he'd done something important during the war, but Brophy deflected questions with characteristic modesty. He died on March 14, 1978, at age 73. The Charleston Post and Courier ran a brief obituary noting his wartime service and civilian career. Most readers had no idea that the man being memorialized had invented a modification that changed naval warfare. The knowledge went to the grave with a craftsman who had measured success by work quality rather than historical recognition. In 1994, the Navy finally provided formal recognition. The Naval Historical Center installed an exhibit at the Washington Navy Yard documenting Brophy's contribution. The display included photographs of pontoon installation, technical diagrams explaining the modification's principles, and combat statistics demonstrating operational impact. A bronze plaque noted that Brophy's innovation had enabled Operation Overlord's success by solving the beaching problem that threatened amphibious warfare feasibility. The exhibit's dedication ceremony included veterans who had served aboard LSTs during Normandy operations. Retired Rear Admiral James Patterson, who had commanded an LST squadron at Utah Beach, provided the keynote address. His remarks captured the modification's significance from a combat veteran's perspective. "Thomas Brophy never wore a uniform," Patterson said. "He never stormed a beach or fired a shot in anger. But he saved more American lives than most combat soldiers ever could. His welding torches fought the war as effectively as our guns. He saw a problem, created a solution, and changed history. The Navy owes him recognition that came too late, but we remember now. We honor him now. And we ensure that his name joins the ranks of those who made victory possible through courage that extended beyond battlefields into shipyards, where anonymous craftsmen built the tools that won the war." Contemporary naval engineering courses teach Brophy's modification as a case study in practical innovation under operational pressure. The U.S. Naval Academy includes his story in its leadership curriculum, emphasizing how individual initiative can solve institutional problems that bureaucratic processes cannot address effectively. The lesson resonates with young officers learning that sometimes the best solutions come from unexpected sources, that expertise doesn't require formal credentials, and that courage includes the willingness to violate regulations when lives depend on doing what's right rather than what's authorized. The broader lesson embedded in Brophy's achievement extends beyond naval applications to fundamental questions about innovation and institutional thinking. One civilian welder saw what trained experts missed. He acted when official channels would have delayed action indefinitely. He created a solution using materials considered worthless scrap. And he changed the outcome of the largest military operation in human history through unauthorized initiative that military doctrine should have punished but practical necessity ultimately rewarded. The modification that began as illegal equipment tampering became the standard that defined amphibious warfare for subsequent generations. The 3 tons of welded steel that Brophy installed without permission enabled the delivery of 2.1 million tons of supplies that kept Allied armies advancing toward Germany. The 42 hours of unauthorized welding work produced capability that prevented 8,400 casualties among LST crews and saved countless additional lives through improved supply flow. The statistics measure impact. The story reveals character. Thomas Brophy possessed the craftsman's confidence that comes from years of building things that must work under stress. He understood that solutions often emerge from practical experience rather than theoretical analysis. And he demonstrated moral courage by refusing to accept that regulations should prevent actions that would save lives. Military institutions exist to channel individual actions toward collective purposes through discipline and standardization. The system works because most people follow rules most of the time. But extraordinary circumstances sometimes require extraordinary responses. Brophy's unauthorized innovation succeeded precisely because it violated procedures that would have delayed implementation until the problem no longer mattered. The tension between institutional order and individual initiative defined his story, showing that sometimes the greatest contributions come from those willing to break rules for purposes more important than compliance. The welding torches that modified LST hulls in Charleston shipyards fought World War II as effectively as rifles and artillery. The compressed air systems that blew pontoon ballast tanks saved lives as certainly as combat medics and evacuation procedures. And the civilian welder who built unauthorized equipment demonstrated courage as meaningful as soldiers who stormed defended beaches. Thomas Brophy never sought glory. He never demanded recognition. He just did what needed doing, using skills developed through years of connecting metal pieces that had to bear weight under stress. The LSTs that crossed English Channel waters on June 6, 1944, carried Brophy's innovation into history's largest battle. The vessels that delivered supplies enabling Allied victory incorporated modifications that began as one man's response to a problem that was killing people unnecessarily. The beaching times that made Operation Overlord possible resulted from welding work performed without authorization by a craftsman who understood that saving lives mattered more than following regulations. Sometimes the greatest heroes are those who never wanted fame. Sometimes the most important victories come from unexpected sources. Sometimes one person refusing to accept impossible changes the course of history through work that others never see but everyone depends upon. The pontoons welded onto LST hulls didn't win the war alone, but they saved the men who did. Remember Thomas Brophy. Remember that courage doesn't always wear uniforms. Remember that innovation doesn't require permission when lives depend on action. Remember that sometimes the greatest weapon isn't on any blueprint. Sometimes it's just a welder with a torch who refuses to watch people die when he knows a better way exists. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.